Okay, this is number 23 in the book. They ask us to find the absolute maximum and minimum of this function restricted to this closed interval, and then use the graphing calculator to check your results. Okay. Well, I've kind of done the graph first, so we can kind of work in both ways, because we're going to go through the process of finding the absolute maximum and minimum. So here's the idea. When you take a function that doesn't have any breaks or anything unusual going on, a nice, smooth, continuous function, and you chop it off. So you only look at it in a closed interval. So starting at -1 and stopping at 3. These are x values. There will be an absolute maximum and there will be an absolute minimum. Now if you look at the graph of this function, and without thinking about that interval, well, clearly there is no absolute minimum because the function moves down indefinitely, and there's no absolute maximum either because the function moves up indefinitely. Okay. However, it turns out that if you take a nice smooth graph and you chop it off, okay, starting at, in this case, -1, and stopping when x is 3, we will have an absolute maximum and a minimum. So here's how it works. Right here is the x-coordinate of -1. Okay. Right here is the x-coordinate of 3. What they're asking us to do is to kind of chop off our function and only look at it between these two numbers. Okay, so we're kind of chopping it off here. Now, my graph is just approximate, so don't try to get anything too precise here. But what we see is that when we chop off a graph and only look at it on a closed interval, there will be an absolute maximum and an absolute minimum. Okay, how do we find this? Well, actually, that's where the theory in the book helps us. When you look at a function, a continuous function, so no breaks or asymptotes or anything crazy like that, on a closed interval, there will be an absolute maximum and minimum, and they can only occur at two kinds of points, either at critical numbers inside this interval or at the endpoints of the interval. Okay. So first of all, we have to look at the critical numbers. What are the critical numbers of this function? Well, to see that, we have to find the derivative. Okay. Derivative of this function is 3x squared minus 6x. Okay. Now, if I take that derivative, remember, critical numbers occur whenever the derivative is 0 or undefined. Okay. Well, this derivative is never going to be undefined, but it will be equal to 0. Okay. If I set it equal to 0, I can factor a 3x out, x minus 2 left, so 3x times x minus 2, just factored out a 3x. Well, I'm going to get a critical number if x is equal to 0 or if x is equal to 2. Okay. Now, both of these two critical numbers happen to be inside of our interval, -1 to 3. Okay. So you look at your critical numbers. Now remember, you may not have graphed the function yet. You ask yourself, are both of these numbers in the interval we're looking at? Okay. And they both are. 0 is between -1 and 3, and so is 2. Okay. But if one of my critical numbers was 5, I would actually kind of throw it in the garbage, okay, because I only want to find maximums and minimums in this interval. So if I have a critical number in that interval, great. If not, it's not important to us. Okay. So where is the maximum and where is the minimum? Okay. Well, basically, that's the great thing. The critical numbers were 0 and 2. The endpoints, which are the other things we need to check, the endpoints of our interval are -1 and 3. Okay, there will be an absolute maximum, there will be an absolute minimum, and each of those has to occur at one of these 4 points. Okay. So how do we find out which and where they are? Okay. Well, that's the easy part. You see, since we only have 4 points to check here, we can just plug those 4x values into the original function and see what y is for each of those. Okay, these are the only 4 points where we can have a maximum or a minimum. So you could say that together the critical numbers and the endpoints are the test points. Okay, these are the points where we can have a maximum or a minimum. Okay, and it's very easy to find. You just look for the y values at each of these points. What's the y value when x is 0? Well, it's f of 0, right? So I get 0 cubed minus 3 times 0 squared, which is 0. Okay. Now when x is 2, I need to find the y value there as well. I get 2 cubed minus 3 times 2 squared. It's going to be 8 minus 12, which is -4. Okay. Now I've got -1. I need to test that one too. -1 cubed minus 3 times -1 squared. Okay, let's see, that's going to give me, looks like also -4. Okay. And finally, that last point, the last endpoint, +3. Well, 3 to the third minus 3 times 3 squared. Oh, that's 27 minus 27, which is also 0. Okay. So actually this one was a little strange in that we have actually 2 absolute maximums and 2 absolute minimums. Usually you'll just get 1 of each, but it is possible to have 2 points which tie. Okay, these 2 points, when x was 2 and when x was -1, they gave us the absolute smallest y-coordinate on this interval. Okay, and we can see that because these are the smallest y values we get out. Okay, -4 is smaller than 0. Okay, so of all of these numbers you've tested in the function, whichever gives you the smallest y-coordinate is the absolute minimum. Well, we had 2 that tied, right? These 2 x values gave us the same y-coordinate of -4. So +2, -4, and -1, -4 are absolute minimums. Okay, and it goes the same for absolute maximum. Of all of these points you've tested, the endpoints and the critical numbers inside the interval, okay, whichever gives you the largest y-coordinate is the absolute max. Okay, well, we have 2 of those. Okay, the largest y-coordinate is 0. And if you look at our graph, that makes sense, right? The largest y-coordinate I have is right here on the x-axis, which means y is 0. So 0, 0, and 3, 0 are our 2 absolute maximums for this function. Okay, and again, remember we could do all of this without looking at the graph. But now that we look at the graph, we see that everything looks right. Okay, for this function, restricted to the interval -1 to 3, the lowest y value, the smallest y value, seems to occur here and here. Those are both tying for the lowest y value. And according to our analysis, those are the points -1, -4, and 2, -4. And my graph's a little off, but that's exactly right. And the absolute maximum, well, the largest y value occurs here and here at 0, 0, and 3, 0. So everything checks out.